Tucked away between the colossal figures of Mount Rainier and Mount Adams in Washington state lies a rugged expanse of wilderness known as Goat Rocks. Its sawtooth ridges, glacial basins, and fractured peaks paint a picture of raw, untamed nature. But beneath this serene beauty lies a secret, a history forged in fire. Goat Rocks is the remnant of an ancient stratovolcano, a giant that roared to life hundreds of thousands of years ago. Today, it's classified as extinct, its fiery heart believed to be cold, and its magma pathways sealed forever. Or so we thought. In the crisp air of early autumn, something stirred. A team of scientists, equipped with portable gas sensors and high-sensitivity thermal probes, ventured into the wilderness. They were searching for whispers from the deep earth, and what they found was subtle, yet profound. Their instruments detected a faint thermal anomaly, a temperature increase of less than 1 degree Fahrenheit, barely a flicker against the mountain's baseline. This warmth was concentrated along a deep structural fault line, a scar from the volcano's ancient core. At the same time, sensitive equipment picked up unusual microseismic activity, tiny tremors, imperceptible to any human. It was the first clue that the sleeping giant might not be entirely at rest. The mystery deepened as the team analyzed the air. They found low concentrations of carbon dioxide and sulfur compounds seeping from the ground. While not alarming in quantity, the origin of these gases was extraordinary. Isotopic fingerprinting revealed the carbon dioxide wasn't from decaying soil or surface life. It came from several kilometers underground, a signature of deep geological processes. This finding suggested that gases were migrating upward, finding their way through fractures in the rock that were thought to have been sealed for millennia. This wasn't the first time Goat Rocks had shown signs of life. Looking back, a pattern of strange occurrences begins to emerge. In the early 1980s, explorers reported warm springs bubbling up at elevations previously considered geothermally inactive. Then, in the early 2000s, remote sensing satellites captured fleeting infrared anomalies, hotspots that appeared and vanished without explanation. At the time, these events were dismissed as isolated curiosities, statistical noise in a vast landscape. But with the new data, these historical footnotes took on new significance. They were pieces of a larger puzzle, hinting at a persistent, residual energy hidden within the mountain's core. The microseismic activity provided another crucial piece. Scientists recorded clusters of tiny earthquakes, each lasting only a few seconds. These tremors originated 3 to 5 kilometers underground, directly beneath the thermal anomalies. Their signature wasn't typical of tectonic fault slips, the kind of quakes common in the region. Instead, they suggested the movement of fluids under pressure, forcing their way through cracks in the subterranean rock. It was as if the mountain's ancient plumbing was slowly coming back to life. To unravel this geological enigma, a multidisciplinary team was assembled. Experts from the U.S. Geological Survey, regional universities, hydrologists, and structural volcanologists converged on Goat Rocks. Their mission: to build a comprehensive picture of what was happening deep beneath the surface. The investigation deployed an impressive array of cutting-edge techniques. After the first snowfall, drones equipped with thermal cameras flew over the area, mapping the subtle heat patterns against the cold, white canvas. High-resolution topography scans searched for millimeter-scale cracks in the soil, evidence of ground deformation. Teams on the ground collected groundwater samples, analyzing them on-site with portable spectrometers. And deep-sensing magnetometric surveys were used to map conductive zones underground, hunting for pathways where water and heat might be flowing. The evidence began to paint a clear picture. The faint warmth and gas emissions were signs of an active hydrothermal system. Warm groundwater, pulsing up along ancient fault lines, was causing the minor soil cracks and temperature anomalies. Isotopic analysis of the water itself was the smoking gun. It showed that the water had been in contact with basaltic rock several kilometers below the surface, heated by the Earth's geothermal gradient. The magnetometric surveys confirmed this, identifying a continuous conductive zone deep underground. This zone aligned perfectly with the structure of the ancient magma chamber, revealing a vast, hidden reservoir of geothermally heated water. But why was this happening now? The answer lies in the grand tectonic ballet shaping the entire Pacific Northwest. The Juan de Fuca plate is continuously sliding or subducting, beneath the North American plate. This immense collision creates incredible compressional stress across the entire region. This constant squeezing is now believed to be reviving the ancient, dormant fractures within the Goat Rocks volcano. The pressure is just enough to pry open these old pathways, allowing deep, superheated fluids to migrate toward the surface. It's a fascinating discovery. The subtle, ongoing shifts of the Earth's crust are mimicking the early warning signs of volcanic unrest, but without any new magma involved. The mountain isn't reawakening in a volcanic sense. Rather, its geological memory is being stirred. The implications of this research are profound. It forces us to redefine what extinct truly means for a volcano. It suggests that even long-dormant giants can host complex and dynamic hydrothermal networks, kept alive by tectonic pressures and residual heat. This discovery has major implications for the entire Cascade Range, home to a chain of volcanoes, many of which are also considered dormant or extinct. Could they too conceal similar active systems, hidden just beneath the surface? The work at Goat Rocks provides a unique window into the planet's deep memory, revealing how geological structures can retain and channel energy over hundreds of thousands of years. It's a story of long-term crustal fluid movement, a process fundamental to understanding how our planet works. The investigation is far from over. The next steps are already being planned. Extended seismic arrays will be deployed through the winter to create a continuous, high-resolution map of the microseisms. In the spring, researchers will return to sample water from seasonal springs, hoping to capture more detailed isotopic data. More advanced techniques, like ground-penetrating radar and controlled source electromagnetic surveys, will be used to build a 3D model of the hydrothermal plumbing. The goal isn't to predict an eruption. Goat Rocks remains a very low threat. Instead, the research aims to understand the intricate dance of heat, water, and rock in an ancient volcanic system. This knowledge is invaluable. It enhances our ability to map geological hazards, helps us understand the long-term processes that shape our world, and reminds us that even in the quietest corners of the Earth, the planet is always whispering. What other secrets are our planet's sleeping giants keeping? And what will they tell us when we learn to listen? Thank you for watching. If you found this journey into the Earth's hidden depths as fascinating as we did, be sure to like and subscribe for more explorations into our incredible world.